Hi everyone. I'm continuing my sequencing series, and yesterday we talked about arithmetic series. Today we're going to talk about geometric series. So, in example number 1, they're actually asking you to find the geometric series. So, all that means is the sum of the terms of a geometric series. Just like yesterday we talked about an arithmetic series, which just means the sum of the terms of an arithmetic sequence. So we are going to take a geometric sequence and we're going to add up all the terms that they're talking about to find our geometric series. Okay, that's all that is. We're going to generate a geometric series. So given this series, now they defined the sequence by a recursive formula. So they tell you a sub 1 is 3, and they give you this recursive formula. So just again, a little reminder, this just means to get to the next term, take the previous term and multiply by 2. So I'm going to write out in this series that they're asking you for, if you notice, they're looking for the sum of the first 5 terms. Remember, this means start at 1, right? Start at 1 and end at term 5. So if I were going to just write out the first 5 terms, okay, a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. We know a sub 1 is 3. It's given. They have to give you 3 in your recursive. So when they give you the first term, in order to get to the next term, just multiply by 2. So you're going 6, 12, 24, and 48. And to find your series, you would just take all of your terms, add them up, and find your sum. When you add them up, you get 93. Okay? So today, best news ever, you're just like your geometric sequence, a sub n equals a sub 1 times r to the n minus 1. Your geometric series formula, here you see it here, to find the sum of any number of terms, s sub n, you have to take a sub 1 times 1 minus r to the n over 1 minus r. And it's funny, I don't usually use that. I actually distribute the a sub 1, and you're going to see it like this. So take note. Good news is both geometric sequence and geometric series are both on your Regents reference sheet. Okay, so you'll see both of those formulas. And if you take note, the one that you see on the reference sheet has a sub 1 because they distributed the a sub 1 times 1 to get a sub 1. And then a sub 1 times r to the n, and your number of terms that you're looking for, over 1 minus r. R is your ratio. Okay, remember your common ratio is just what you are multiplying to get to your next term. Okay, so they're actually going to ask you to, and I'm going to show you how you're going to do this in the calculator. They're asking you to take that do now question and use your formula to do your do now question. So again, I am going to just write your formula down. I'm going to use S of n equals a sub 1 minus a sub 1 times r to the n over 1 minus r. So here we're looking for the sum of the first 5 terms. Okay, so we knew a sub 1 was 3 minus 3 times our common ratio was 2. That was what was happening every single time. We were multiplying by 2. R was equal to 2. We're going to raise that to n. N is 5, the number of terms that they want the sum of, over 1 minus r again, which is 2. Okay, so to get the sum of those first 5, here's what you're going to do. I'm going to go right into my calculator. I'm going to put that formula again. I'm going to immediately hit my division, and I'm going to do 3 minus 3, my first term, times my common ratio of 2 raised to the 5th power, and I'm going to divide that by 1 minus my common ratio of 2. And you see there, you get 93. And that's exactly what we got in our do now question, okay? So that's just using your series formula to get your series. Okay, so let's take a look at number 2. Let me do another one with you. Which of the following represent the sum of a geometric series? Okay, and now they're talking about 8 terms. With 8 terms, okay, they tell you the first term is 3 and the common ratio is 4. So let's just write our important information. We know that our first term, a sub 1, is 3. Our common ratio is 4. And we need the sum of 8 terms. So again, I'm going to write my formula down. S sub n, okay, is going to give me a sub 1 minus a sub 1 times that common ratio to the n over 1 minus our ratio. Okay, so if I want the sum of the first 8 terms of this geometric sequence, I would take my first term, 3, minus 3, times that common ratio, which is 4, to the 8th power, over 1 minus that common ratio, again, is 4. Okay, so when I go to the calculator, I'm going to once again hit my division sign. I'm going to do 3 minus 3 times my ratio of 4, and I'm going to raise that to the 8th power, and I'm going to divide that by 1 minus my ratio of 4, and there's my number, 65,535, 65,535, which is choice 4. Okay, let's take a look at number 3. Good question, number 3. Number 3, they're talking about a person placing 1 penny in a piggy bank. Okay, so let me just highlight. 1 penny is going in this piggy bank on the first day. So I'm immediately thinking, okay, let's simplify and say a sub 1 is 1. 1 representing 1 penny. Then it says 2 pennies on the second day. Okay, so that means a sub 2, 2 pennies. But then it says 4 pennies on the third. So a sub 3 is 4. So when I start to think about this sequence, I know it's going 1, 2, 4. Now I can continue. After 4, obviously, it's doubling. 8, 16, 32, and I'm going to keep going. What do I know my common ratio is? My R has to be 2 because it's doubling. Now it says, will this person be a millionaire at the end of a 31-day month? Show the calculations that lead to your answer. So if I want to know after 31 days, so I mean I have here day 1, day 2, day 3, day 4, day 5. I only have day 6. I'm not going to just keep doing it until I get to 31 days. I want to get to the 31st term in the sequence. Okay, so to do that, we're going to use our formula. So again, I'm going to write my S sub n, a sub 1 minus a sub 1 times my common ratio to the nth power over 1 minus my common ratio. So instead of here, n, I know n has to be my 31 days. My a sub 1 was my 1 penny. Minus 1 times my common ratio has to be 2. I'm going to raise it to the 31st power over 1 minus my common ratio of 2. Okay? So now remember, when you go to the calculator and we calculate that, we have 1 minus 1 times our common ratio of 2. I'm going to raise it to the 31st power, okay, and that's over 1 minus 2. It's a big number. Okay, so I'm going to write that number down. It looks like pretty big. 2,147, 483, 647. Thousands. So it looks like 2,147,483,647 pennies. Remember, that's pennies. So what would you do with your pennies to figure out how much that is in dollars? You could really take your pennies and you could divide by 100. And that's going to tell you how much money you would have. If you divide that number by 100, you're going to get let's see. It looks like 21 million. Hold on, Lucy. 700.
I saw Danny.
474,836.47. So, is this person going to be a millionaire? Yes. Right? I would immediately say yes. This person is a millionaire. Okay. I am going to stop there. Lucy needs me. You guys are going to try to do the next few 4, 5, 6, and 7 on your own. I will post the answer key. Okay. Have a good